So, with all these squares that you quickly divided into half and quickly shaded into a half, because I said quickly do it. So we are, because I'm moving on without you because I said quickly do it, so you should be done. So we have it in half. So with this one, going from 1/2, what they did was they multiplied the top and the bottom by 2. All they're saying is they split it in half into 2 parts. So now we have 2. What? 2 parts that are shaded out of a total of 4. Did we change that there's still 1/2? No. So what I want you to do on one of your pieces of paper that is colored in, I want you to draw a line going the opposite direction horizontally to show 1/2 is equivalent to 2/4. So you have 2. And so you should have 1/2 that's shaded in because I told you to do it quickly. 1/2 should be shaded in because I told you to do it quickly. And this one that you did right here, half of it should be shaded in already. So 1/2. What you do to the top, you do to the bottom. If you see, you have 1/2. They multiplied the top by 2 and the bottom by 2. What you do to the top, you do to the bottom. You cannot do multiply by 2 different numbers. So 2 out of the 4, 2/4 is equivalent to 1/2. So I want you to pull out one more of your squares that is shaded a half. And I want you to take that one and split it up into 3 sections. You're going to draw 2 lines across it. You do 2 lines, you get 1, 2, 3 sections. 1/2 times 3 on the top, 3 on the bottom. What fraction is equivalent to 1/2 in your square when you've done that? What complete fraction? 3/6. Because I have 3 shaded out of a total of 1, 2, 3, 4, 5, 6. Did I change the fact that there was still half of it shaded?
No.
No. But now there are 1, 2, 3 shaded out of 6. 3/6 is equivalent to 1/2. They're equivalent. All you did was make it a bigger fraction. Different numbers, but it's still equivalent. I want you to take this one and put it in 4 sections. And on the back, I want you to tell me what fraction is equivalent. On the back of your square, give me the equivalent fraction. Okay, so if we took this one and we divided it into 4 sections. So, there's that. 2, 3 lines. 1, 2, 3, 4 sections. What is your equivalent fraction? 4/8. So 1, 2, 3, 4 out of 1, 2, 3, 4, 5, 6, 7, 8. So you have 1/2, and you multiply the top by 4 and the bottom by 4. Very good. Okay. Move that out of the way. It's in my way. Okay, I want you to take this last square and put it in 5 sections and write the equivalent fraction on the back. Okay, we do 1, 2, 3, 4. What is the equivalent fraction? 5/10. We still have a half, and now we've gone 1, 2, 3, 4, 5. So times 5 up top, 5 down below. Any questions about that? Okay. So I want you to turn each 1/3 into a different equivalent fraction. Each one. Then I'm going to call on you to basically give it to me. Tell me what you did to turn it into an equivalent fraction. So you can take this way. Going to 2 parts. 1 and 2. Top by 2. Bottom by 2. 2, 6. Yes, no, maybe. Made it very, very easy. Not going to Megasonic with it. Okay, Marlon, what did you do? So, you 5 sections. So 1, 2, 3, 4. So 1, 2, 3, 4, 5. So then 1/3 is equivalent to 5/15. So you still have 1, 2, 3, 4, 5 that are shaded out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It's still 1/3, but now it's 1, 2, 3, 4, 5 out of 15. It's equivalent to 5/15. So anybody do that one? Good?
I did that one.
Okay, Stanley, what'd you do?
3.
So split it into 3 sections. So 1, 2, 3. So 1, 2, 3 out of 1, 2, 3, 4, 5, 6, 7, 8, 9. 3 ninths. And Lee.
I did 2. 2 lines.
Oh, so that's that one?
Well, 3.
3 lines? Okay. So 1, 2, 3, 4. So 1, 2, 3, 4. Out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I know there were some super mega problems that I saw Logan do. He took it and ran with it. Yeah, he did 1/3, 8/24. Is he wrong?
No.
No. He just went kind of extra with it. But is he wrong? No. Now there will be some problems when we're adding and subtracting fractions that he may need to go larger like that. Because when you're finding common denominators, you might have to go that high. So nothing wrong with that at all. Ma'am? Don't talk so softly, I end up making a face at you trying to hear what you're saying. Continue the pattern with 3/4. So let's see, now we're not doing units. That's not very good. I didn't do that one very good at all. So now instead of doing unit fractions, which means that there's a 1 in the numerator, Now there's an actual number in the numerator. So now I have to do fourths. So there's a half, number. So now we have 3 out of 4. So I want you to see if you can find an equivalent fraction to 3/4. Half of that, half of that. You see how I'm not spending all year long coloring that in? I'd much rather do the math. Okay. All right, Cameron, what did you do for the first one? Or just give me one. I'm doing the first one. What did you do? Just give me one. That won't take me an hour to do.
Mm-hmm.
Yeah, I
That
had
means you and you.
1,
Or
2.
you.
So I'm multiplying by 3. 1, 2, 3 sections. 3 on the top, 3 on the bottom. So the equivalent fraction is 1, 2, 3, 4, 5, 6, 7, 8, 9 out of 12. You guys, I get that maybe you really like doing the squares. If you like doing them, great. But you also need to really work on doing the math, because you're not always going to have squares, and you have to be able to do the math. Because if you go home and you bust out these squares, your parents are going to be going, what is that teacher teaching you? This is how I did it when I was in school. And eventually, you know what I'm going to be doing when we're doing adding and subtracting fractions? The math. I'm not busting out a square, especially if it's going to be something like 5/16 or something. I'm not drawing a square. I'm just going to do the math. The math, the square is just to show you how or why the math works. That's all. So it's really just there as a guide to show you why you're doing this. But don't get so reliant on this that you're not doing the math. That's why a lot of times I don't do manipulatives, because y'all are like, I'm not even going to bother learning the math. You still have to do the math. You had to do both. All right, KJ. Not something ridiculous. Huh?
Not that bad.
Yeah.
I did 10 lines.
So you want me to draw that with a fat smartboard marker? No, I'm not doing either. 2, 3, 4, not gonna fit. 6, 7, 9, 10, not even fitting. Times 10. See, again, that's why you, because sometimes you can't fit it in there, it doesn't really work, so you have to be able to do the math.
That's 11.
30, 40.
There wasn't one of
All right. So, Malachi, something normal? So your equivalent fraction is? What is your equivalent fraction? What?
He drew 4 lines.
Oh, you drew 4 lines. Oh. Sorry. Your equivalent fraction is what? All right, and right. Four lines or 4 sections? So
We always did that.
What did you get? That's 1, 2, 3. Okay, I'm doing this one. I see your math. You did too many lines. Okay. Oh my gosh. 4, 4, 12, 16. You just did too many lines. Okay. You got too many. Never mind. Okay. So I'm going to show you something else that's not this. Okay. Yeah. This is, please don't start talking. And I'm still recording. Am I having to correct you for the talking? Really? I have a problem that I was going to do. Okay. This is related to something that we're going to have to do. So you don't need any pencils. Put the paper down. All eyes up here. All ears up here. So if we had a problem that says if 15 kilograms of rice are separated equally into 4 containers, how many kilograms of rice are in each container? Well, we know right there that if I had a bar model, which you always go, oh, every time we do a bar model, which you have to do. If we're doing a word problem back there, problem of the week, what do you have to do? A bar model. So we have 15 total. How many containers? 4. Thank you for listening. 4. So that means I've got 1, 2, 3, 4 sections. That's how you do a bar model. That's it, right there. That's a bar model. That's it. That tells me that I have to divide. That's it. That's the bar model. That just means divide, because I'm having to find out one of them. I have the total. It's split up. What's 1? So 4 divided into 15. Now, my purpose of this is to show you that there are different ways that we can write this answer. So I'm going to show that to you now. So can 4 go into 1?
No.
No. Can 4 go into 15?
Yes.
Yes. How many? 3. 3 times 4?
12.
12.
3.
With 3. So right now, I'm going to not do 3 remainder 3. I'm not going to do the R3. What I'm going to do is I'm going to lead this into something that some of the other math classes have done. I did not do because we weren't doing fractions yet, and I didn't want to blow your mind. Well, now we're doing fractions. Now, have you heard me tell you that division is the same thing as fractions? Fractions are division.
Yes.
Yes. And if you're just telling me no, then that means that you weren't listening. So, have you seen something like this before?
Yes.
1 whole and 1 half.
1 and 1 half. So, I'm going to show you how to take this and turn it into something like that. Woo! Okay. So, the number up here, your answer, your quotient, is your whole number. Big 3. Your remainder is your numerator. Your divisor is your denominator. So it's 3 and 3 out of 4. 3 and 3/4. So if you wanted to do, if you had to do a division problem, and they said, write your answer as a fraction. That's how you do it. 3 with 3 out of 4. So this would be like something where you would have your answer that would have a remainder of 1 and your divisor was 2. So that might have been like 2 divided into 3. 2 goes into 3 once. 1 times 2 was 2 with a remainder of 1. So it's 1 with 1 with 2. So 2 goes into 3 once with 1 left over as a 2. Okay. Now I'm going to show you how this answer is actually related to decimals. You ready to just kind of go, oh my God, stop. Not everybody knows this.
I can.
Chill. I'm not asking you. Okay. We know how to divide where we get decimals, okay? We've done this. Y'all I already know this on show list. So 4, 15, there's the 3, there's the 12, there's 3. Okay. So when we're dividing with decimals, can we have remainders? No. What do?
You add below.
Decimal, add the 0, bring it down. Can 4 go into 30? Yes. How many times? 7. Shame on you. 28. There's a multiplication chart right there, and I cannot believe that. So 2. Still no remainder. Bring it down. 4 going to 20? 5. So now I have 3 and 7,500. Okay. Now, 3 and 7,500. Oh. All right. 3/4. The fraction 3/4. Oh, 7,500. 75 out of 100 is 3/4. It's the same thing as, these are the same thing. Those are equivalent. This is the same thing. Three-quarters. You're buying a snack. 75 cents is 3/4. How do you say this? 3/4. Or 3/4. But we also say 3/4. It's the same thing. So 7,500 is the decimal way to show 3/4. I see you, Cameron. It's the same way to show that. Same thing. So this is the decimal way to show that fraction. This is the fraction way to show that decimal. Now, I was asked this morning, can we just, because it's like if there's an easy or lazier way that I can do my math, I'll do it. If you're taking a test and it says, write your answer as a fraction, you have to write it as a fraction. If you give it to me as a decimal, I'm going to be like, it says fraction. It might say decimal or fraction. Then you could do either one. But if it says, write your answer as a fraction, then you have to write it as a fraction. If it says, write it as a decimal, then write it as a decimal. So you have to make sure you read your directions. If it says or, then you can do either one. So you just can't, oh, I want to do decimals because I like that one better. If it says fraction, you have to do fraction. So you get that part? So, I mean, I got some people that are like, well, I'm going to pick this one. You have to do what the directions tell you to do. Any questions? We're going to do this again. I was just showing it to you. Mm. Yes?
If it says decimal or fraction, you do both.
You want to do the problem twice? You're so weird. Yes?
So, if you have 3 and 7,600, like how do you put that?
That's what I was doing. You just
That's like that. Because, I mean, how you say it as a decimal is how you write it as a fraction. 76 hundredths. 76 hundredths. How you say it is how you write it. That's why I was always on you to say your decimals correctly and not 0.75. You can't write that. 76 hundredths. 8 tenths. 8 tenths. How you say it is how you write it. 75 thousandths. How you say it is how you write it. People got on, they were so irritated with me because I kept correcting them. That's why. Yes.
Now, what if you see the 4, 3 quarters? What if the 4 was a 5?
What if the 4 is a 5?
How would you call?
3/5? 3 3/5?
You say like 3 quarters? Then how would it be?
3 3/5. It just wouldn't be anything. It's just 3 3/5.
Oh.
It just wouldn't be equal to that. Oh.